Have you ever seen a picture of an atom? It probably says something like this. But where did this idea come from? How can we have a picture of something that's so small that we can't even see it? Well, it all started with Democritus. He was an ancient Greek philosopher who lived around 400 BC, and he was the first person to come up with the idea of an atom. He actually used the word atomos, which is a Greek word for uncuttable, or smallest indivisible particle. One story to how Democritus came up with this idea was that as he walked on the sand, he thought of how the sand used to be pebbles. These pebbles would have broken apart to form the sand, and he thought that the sand would eventually break down into smaller particles, and so on, until it couldn't break apart any further. The particle that would be left was the smallest indivisible particle, in other words, the atom. There were really two main parts to his theory. Atoms are indivisible, and they are also indestructible. Democritus was far ahead of his time, but his idea lacked experimental evidence and was simply based on reason. At the same time Democritus lived, there was another popular idea to what matter was made of. This idea was proposed by Aristotle. Aristotle was another ancient Greek philosopher who lived around the same time as Democritus. Aristotle did not believe that matter was made up of tiny particles, called atoms, but rather matter was made up of 5 basic elements: earth, water, air, fire, and ether. Although Aristotle's idea wasn't correct, his idea was more widely accepted than Democritus' idea for about 2,000 years. Both Aristotle and Democritus lived before the development of the scientific method, and so their ideas lacked experimental evidence. It wasn't until the early 1800s that a man named John Dalton developed the atomic theory that would be based on his experimental evidence and observations. John Dalton was an English school teacher who studied gases. He studied how gases combine, react, move, change with temperature and pressure, and through his research he developed his idea called the atomic theory. Dalton's theory has 5 main postulates. First, he said, all matter is composed of atoms. Next, he said that atoms cannot be created or destroyed. His third postulate is, all atoms of the same element are identical, and so different elements have different types of atoms. Next, he said that chemical reactions occur when atoms are rearranged. And finally, he said, compounds are formed by the combination of 2 or more different kinds of atoms. There was a lot that Dalton didn't know about atoms. However, his theory is still useful as the basis for the modern atomic theory. Dalton's idea that atoms are indivisible was held to be true for almost the next 100 years, until the work of J.J. Thomson. He was another English scientist who worked in the late 1800s. Thomson discovered that the atom could be divided, and he discovered a negatively charged part of the atom called the electron. J.J. Thomson worked with a device called the cathode ray tube, also known as a Crookes tube. This device was a sealed glass container that has 2 electrodes separated by a vacuum. When voltage was applied across these electrodes, cathode rays were created. In other words, a stream of electrons that would move across the glass tube. When the particles struck the other end of the tube, a glowing patch was created, thus visualizing where the particles were. Thomson discovered that if he used a magnetic field, he was able to move or deflect these particles. These particles would also be moved by an electric field, and Thomson found that these particles would always move towards the positive charge. He was thus able to conclude that these particles were negatively charged. Thomson revised the atomic theory to include these particles. He called his theory the plum pudding model. In this model, the atom is represented by a traditional English dessert. It's kind of like a chocolate chip cookie, where the chocolate chips represent the electrons, which are embedded in the rest of the atom, and the rest of the atom would be represented by the cookie.